Hello everyone. Today, I'm here again with a nice geometry question. This one is from the Oxford admission test. It was asked in the year 2023. I had previously solved another question from the Oxford test in short format, and I will continue solving problems from top universities in this way, so that you folks can see how these things are done around the world. That's why I recommend you stay subscribed. Also, there's something interesting in the question, but I can only mention it at the end of the video, because it will only make sense then. So what does our question say? ABCD is a square, with each side being 1 unit long. The circles are tangent to the sides and to each other. The area of the larger circle is 10 times greater than the area of the smaller circle. What is the sum of the radii of the two circles? It would be better if you pause the video now and try to solve it yourself. Now we are asked to find the sum of the radii of the circles. That means I need to somehow bring both radii together. For example, if I connect the centers of both circles and call the radius of the larger circle capital R and the radius of the smaller circle lowercase r, then essentially we are being asked to find the length of this line. Now, let's form a right triangle where this line is the hypotenuse. If I can find the lengths of the triangle's sides, I can apply the Pythagorean Theorem. Now, if I draw two lines from the large circle's center to the tangent points, each of those lines would have a length of capital R. If I do the same for the small circle, those lines will each be lowercase r. Now, if I connect the tip of the right triangle to side DC, what would its length be? There's a rectangle there, right? So that side will also be lowercase r. Since one side of the square is 1 unit, then one side of our right triangle will be 1 minus capital R plus lowercase r. Okay, good. Now let's find the other leg of the triangle. If I connect the tip of the triangle to side BC, what would its length be? Yes, you guessed it, capital R. So the other leg will also be 1 minus capital R plus lowercase r. Now we've completed all sides of the triangle. To simplify our equation, let's call capital R plus lowercase r equal to x. Then, the triangle has two legs, each of length 1 minus x, and the hypotenuse is x. We'll now apply the Pythagorean Theorem. 1 minus x squared plus 1 minus x squared equals x squared. When you expand and simplify this equation so that everything is on one side, you get x squared minus 4x plus 2 equals 0. Now we have a quadratic equation, but its solutions are not integers, so we need to look at the discriminant. What was the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1, b is negative 4, and c is 2. Plugging in those values, we find the two roots of the equation. 2 plus square root of 2 and 2 minus square root of 2. Now, which one is the correct answer? It can't be 2 plus square root of 2, because that is greater than 1. The triangle sides is 1 minus x. If x is greater than 1, they become negative. Therefore, the correct answer is 2 minus square root of 2. Interestingly, the answer to the previous Oxford question was also 2 minus square root of 2. But, as I mentioned at the beginning, this is not the most interesting part. If you look at the problem statement, it says the area of the large circle is 10 times greater than the area of the small circle. But we never use that information at all. Why do you think they gave us that detail? I'd love to hear from you who tried to solve the question using that information. Did you use it, or did it just mislead you? Let's discuss it in the comments. See you in the next video.